Hello, everyone. Thank you for joining us today. My name is Ruslan, and I'm excited to introduce the speakers today. As enterprises ramp up their API programs, IT teams are looking for ways to abstract away the complexities of developing APIs and speed up the development process. One of the opportunities to do that is using cutting-edge cloud services to abstract away the complexities and add to your APIs. Today, we're going to be focusing on one of those services, specifically the data loss prevention service, in order to ensure the security of your APIs by abstracting away the complexities related to identifying and masking sensitive data. Our speakers today are Prithpal, Bhogill, who's the product manager on Google Cloud's Apigee team, and Scott Ellis, who's the product manager for Cloud's DLP. Prithpal, take it away.
Okay, thanks, Ruslan. Super excited to be here. Again, welcome. So let's kind of talk a little bit about what are our customers doing today. When we talk to several of them, many of them are at some point of time in their digital transformation journey. And essentially, what that means is a lot of the enterprise digital assets that they have that could be hidden in some backend systems, databases, even new cloud-native applications that they're building, well, many of them need to be able to convert into APIs to deliver the connected experiences, which is the hallmark of any kind of digital transformation effort. So what that means is because they're building so many APIs and they're innovating, they also need to be able to build these APIs fast and in a much more secure way. As we start to dissect what customers are doing from their APIs, the move to the cloud has become very real, and they're leveraging more and more cloud services within their APIs. And so today we're going to look at how customers can use Apigee Edge to be able to accelerate the API development while using some of these cloud services. So let's just break down how does one access a cloud service. If you look at any cloud service out there, we believe it has 4 high-level steps. So one of the very first things you have to do is first determine what my credentials are to a specific cloud service. Next, then I need to be able to figure out how I manage persistence of those credentials, and then call this token endpoint, which is give me an access token that I can use to access this service. Step 3, then I have to actually store and manage the access token. And then finally in step 4, once I have the token, I then use that to actually call the original cloud service that I really intended to. So as a developer, I have to really take on a lot of complexity. And if I'm doing this thing for one API, just imagine that I'll be doing this thing for the 10 APIs that I'm building. Well, it turns out many of these things don't work out very well because they're error prone. I'm doing a series of steps again and again. It takes a lot of time, redundant steps. And then last but not the least, administrators are never happy about letting a developer work with any credentials. They want clean separation of controls where they are working with services and credentials, and developers are really using some of those capabilities. So how can we really simplify the experience for the developer, yet make it easy for them to consume these services at a very fast pace? So today we're going to be talking about a feature of Apigee Edge. So Apigee is a full lifecycle API platform, and it has all the bells and whistles to be able to offer API security. You can have out-of-the-box policies to do things like traffic management, transformation, and it can power an entire API program, whether you're starting small or whether you're a big enterprise, whether you want to reach the level of monitoring APIs. It has all those core capabilities built into the platform, along with end-to-end analytics and monitoring. But Apigee Extensions is a new feature which was introduced last year, and we built a series of new extensions that we recently released at the Google Cloud Next. These extensions are nothing but packaged offerings to be able to easily connect to some of these cloud services. And it makes it easy for application developers as they are leveraging more and more of these cloud services, instead of interacting with them using the 4 steps that we spoke about. Of course, Apigee is an extensible platform, and you can pretty much just use any policies out there. What we saw over time is this specific pattern of accessing a cloud service is something which needs to be repeatable. It's something which also needs to be reusable within the enterprise, because as the adoption of cloud services is on the rise, developers want to build APIs consuming these cloud services much faster. So what I would like to do at this point in time is actually talk about a very high-level use case scenario. I will do one quick demo which will focus on what Apigee Edge is and how we can quickly build an API. But we have a 2-part demo series, and after this demo, we'll actually talk about what DLP does, data loss prevention does, and how it can really help enterprises secure sensitive data. So at this point in time, I'm going to share my screen. So what you're seeing out here is the Apigee Edge user interface. So in this scenario, imagine I'm an API developer, and I want to very quickly build an employee API. And I want to be able to connect and get some data out of BigQuery as an example. And that's where my employee data set is stored. And I want to be able to easily access that data. So one of the first things you do in the Apigee Edge platform is you go and build this thing what we call as an API proxy. An API proxy is a very, very basic and core construct. As an API developer, I can go and click on the plus proxy icon, and I can choose a variety of different flavors, whether I'm using just a simple reverse proxy endpoint, which is one of the most common use cases, or whether I'm converting SOAP to REST. You can also, use Node.js as an example to build out the API proxies. So you can go through these steps and actually go and build a full-blown API. But what I'm going to do as part of this demo is going to show you an existing API called Employees API. So right now I'm in the overview definition for the API. So you can see what different kind of endpoints it exposes out here. And if I hover over to the Develop tab, what I see out here is what we call as the API Proxy Editor. So I'm going to really quickly switch on to revision 2, which is the one I want us to look at right now. So I'll just walk you through this API proxy really quickly. As you see, one of the very first things that happens when an API call is made is we just verify the API key just to make sure that a legitimate requester is calling this API. Within the API editor, I can actually choose from a variety of different kinds of policies for traffic management, quotas, site arrest. Let's say if you want to use caching. We have a bunch of different kinds of security policies to secure the APIs, and then a bunch of mediation policies if you want to do transformation, so on and so forth. And the platform by itself is extensible, so I can use any of these capabilities, write some code snippets, and I can really extend the platform to the way I want it. Okay, in this scenario, there's a list employee flow, which actually uses a capability called Apigee extensions. I'll just get back to that capability in just a couple of minutes. But let's assume I'm getting data back from the BigQuery data set, and I want to be able to return that data set. So let's just take a very quick peek at how may I actually run this API and get some data back. So in this case, I'm going to switch to a REST client, in this case, Postman. And out here, you can see that I am on the list employees method. If I hit a send request out here, what's really happening is it's actually making a call to the Apigee API in the backend. And this trace tool will actually tell you how the request has been processed. You can see that it called the verify API key, which ensured that every request which is coming in is secure. It made a call to BigQuery, and it got some data back, and is returning this employee data set back. So if I go back to my REST client, I can see that I got the data back. So this is a very basic, simple step one. So let's maybe take a peek through this and figure out how did we really achieve this thing, and what was the speed part of building this API faster by using certain cloud services. So for that, what I'm going to do is quickly go on to an area within the Apigee Edge UI known as extensions. So this is where we have a lot of extensions that we've already pre-built for our customers. So you come into the extensions tab, and this is a classical activity that the administrator of this Apigee Edge org would be performing. So you would come out here, and you would add an extension, and you can see we have several extensions to various Google Cloud services, including the one that we'll be showcasing today, the Google Cloud Data Loss Prevention extension. So as you start to look at this extension, you can configure it, give it a name and description, and you can see the variety of different kinds of other extensions we have, including extensions to a bunch of other kinds of services as well. So we'll go back to the data loss prevention APIs. If I go back to extensions, it should pull up a list of all the different extensions that I already have configured. So let me add the word DLP out here. I can search this specific extension instance, which is configured. And at this point in time, you can see that I can go out here, add the GCP project ID, which is the one that you are using the DLP API from, add some kind of basic information types in here, and then add my service account. That's how you would end up configuring a simple extension. In this case, this shows you how a deployed extension looks like. The administrators really like this because now they are the ones who configure the extensions, they deal with credentials, and they can get access to logs around how is this extension in general working, right? They are tasked in doing this. And if we now flip over back to the API proxy out here, we'll go back right into the employees API proxy. And in that, you will actually notice that we have used, in the list employees flow, that is something that we just invoked, we use a BigQuery extension. So the way to add the extension is pretty simple. You actually use the extension callout policy, and you pick the specific extension that has been deployed for you. So in this case, here is a BigQuery employees extension. And we'll walk you through the DLP extension in the second demo here as well. But now this extension makes all the methods that are available in the BigQuery APIs just as simple calls that a developer can do. And once the developer uses the extension, all they have to do out here is configure the data set and the table that they're after, and the platform manages the rest. They don't have to worry about credentials. They don't have to do any kind of maintenance and management of access tokens. The developer interface is very simple. And this really takes up API development at a higher level in terms of making it super easy to consume these APIs and cloud services and build your APIs faster. So what I'm going to do at this point in time is I'm going to stop my screen share. And at this point in time, we're going to switch focus slightly. So now we will get a little bit into what the data loss prevention extension is all about. We'll have Scott kind of touch on how does the data loss prevention service to begin with offer this kind of protection, what different options are. And once Scott is done, we'll come back to Apigee Edge and show you how you can easily consume the data loss prevention service and secure sensitive data within your APIs. With that, Scott.
Great. Thanks, Prithpal. And I think you showed how the Apigee extensions can really make it easy for administrators and developers to both deploy APIs and have that enterprise-grade control over your APIs. So we're going to talk about how the DLP extension can give those same admins and developers a level of data protection across all their APIs. But before we do that, let's dive a little bit deeper on what our cloud DLP can actually provide. So what we're going to do is first, let's just kind of dive in a little bit and understand what sensitive data is, the kind of things that we're going to protect against. So just some basic examples of sensitive data. These are things like personally identifiable information or PII. It might be related to financial data, health data, and it could come from a variety of sources. It could come about your users, it could come about your employees, or it could also be something that is shared between your partners. And so sensitive data can enter into your enterprise in a lot of different ways. And as you're building your APIs, since you're interacting with all of these sources, we want to show you how you can protect and understand where the sensitive data is flowing throughout your enterprise. And really, the goal that you have when you're dealing with sensitive data, we kind of summarize it in two goals here. One is you want to use that data properly, and you want to minimize exposure. You can kind of relate this to some concepts around least privilege or need to know. But the basic idea is if you don't need a bit of sensitive data to do something, then you don't want to collect that or you don't want to expose that. The second part here is how do you be accountable? And the key thing here is you can have a policy that says how to use data properly, but you really also want to be able to demonstrate that. And so really be accountable from an audit perspective or just from a best practices perspective. And so really with these controls will help you do both of these. So how can cloud data loss prevention help? What cloud data loss prevention brings is the ability to discover and classify sensitive data, as well as de-identify or mask that data. And so out of the box, when we talk about discovery and classification, what we're talking about is the ability to go in and look for things like credit card numbers, social security numbers, different types of PII that may be kind of global types, they could be country specific. And so out of the box, our cloud DLP infrastructure has about 90 built-in classifiers. And then you can go in and create your own custom classifiers, or augment the ones that we have. Once you find the data, the next thing you might want to do is actually go in and figure out how to obscure the data. And this is a process known as de-identification or data masking. And so the idea here is, let's say you find a credit card number in a particular set of text or a request or response coming into your API. You want to actually potentially go in and either just redact that out or mask it somehow. The animation that we're showing here is kind of showing a little bit of a before and after on some structured data. And we're just showing the application of a variety of different techniques here. Things like format preserving encryption, where we can actually take an identifier and produce another identifier that obscures the data but still keeps a lot of the integrity of the original data, as well as doing different types of masking or partial masking. And in that last column, the comment field, we're showing something very powerful here. We're actually combining our inspection and our masking together to actually go into the text here. And if you notice in the comment field, we're going in and looking for sensitive data and only masking that part of the comment field that has the sensitive data. And that's something that we'll show an example here too in an API scenario. So how can this help you with your production workloads? So let's just look at an example scenario. Let's say that you have a customer support chat application. And in that chat application, you have a customer and a support agent just communicating back and forth. And in the context of that chat, the customer decides to overshare. They decide to give more information than you actually need. So in this case, we were looking for the last 4 digits of their social to validate their account. But the customer gave their full social, their phone number, their email address. They give a lot more information than the support agent wanted. And we may not want to collect that information. We may not even want to show it to the agent. So by using our inspection and masking tools, we can actually go in and mask that data in real time, either before the agent saw it or before we persist it to disk, depending on what you want to do there. And so this is just a very high-level scenario here. And next, we're going to go in and kind of show a little bit deeper examples of how this might work on APIs. So really, with Apigee and Cloud DLP, how can we give your enterprise that data protection across your APIs? So admins can apply this from an admin perspective, or developers can take advantage of it. As easy as how Prithpal showed earlier, just applying an extension and deploying this. So let's walk through a couple examples. So first, imagine this, how your enterprise is working. You've got clients at the top here coming from a variety of different sources. Behind the scenes, you've got all of your actual services, your storage, everything going on there. And the arrows represent the various interactions between your backend systems and your clients. And what we just want to highlight here is this red arrow, let's say, contains sensitive data, and it's some sort of sensitive data going out to someone on the web, a user on the web. That could be a potential data exposure. And so again, sensitive data going out would be something where you might be revealing something from an internal system and exposing it externally. Whereas something coming in on a request, the second red arrow here, where maybe a partner is sending you information to your API that you don't intend to collect. Maybe it has sensitive data in there that you don't want to log or you don't want to collect. And that could be an example of a potential inadvertent data collection. And so when you think of things like data minimization and least privilege and need to know, you really want to look at how can I reduce these exposures as well as reduce collecting this information that we don't need. And that's where the Apigee API platform with the Edge extensions and Cloud DLP can really help you inspect and mask across all of your APIs. So the arrows now that are showing in green, we're basically saying like we can actually apply that policy so that you are only exposing and collecting the information that you intend to. So let's walk through just a high-level example of these. So let's say that you have an order API. And in this order API, the intent is that the requester is going to send in an order ID, and then you're going to respond back with a status, maybe a transaction amount. But in this example that's highlighted in the red box, we have a user of the API decides they're going to also include an email address and a raw credit card number in the request. Now, this isn't something you need to process the request, but it may be something that you just accept and end up logging because you logged the request that came in. And even though you don't need or use that information, you really don't want to log it, and you shouldn't be collecting it because that's not the purpose of this API. So when we talk about inspecting and then applying DLP across your API, what we're really saying is you don't want this information. And with DLP, we can go in and do something like masking it. So now this request comes in, the order ID is preserved, but the email address and the card number are just automatically masked out of the request parameters because you didn't need them. So now when you log this information, you're still going to see that this partner or this requester sent that information. You're just not logging the actual raw sensitive PII. Now, because you were showing the redaction there, but you really have the full power of our cloud DLP infrastructure. So it may be that you want to collect that information. You don't want to just redact it, but you want to do something even more powerful. So let's look at that similar example here. But instead of just simply redacting the information, because you have the full power of the tokenization and masking, you could actually go in and use tokenization methods to obscure that data, but still keep the integrity. And what we mean here is that long token that you see there for the email address and the credit card number, keep integrity, because if multiple requests are coming in with the same email or credit card number being sent, you actually can still join and match on that information. You keep the integrity there, but your API is not logging or collecting or preserving that raw PII. You're using a token instead. So that's a very powerful thing that you can do with as simple as changing the configuration on the DLP side. So now let's just look at a similar example, but in reverse. Let's look at a potential data exposure. So let's look at that same order API. Someone sends in an order ID, and your intent is that you want to share out the amount and the status. Maybe this is a product that's being ordered, and we want to show here that it's been shipped. But you also have a note field that you expose, because maybe that note has some very important information that you want to share with the requester. But in this example, we've shown that the note actually contains, in the comment field, a credit card number, and you did not intend to expose that. So by applying that same policy that we saw before, but on the outbound, on the responses here, again, that sensitive data, we can mask inline so that the requester still gets the amount, still gets the status of shipped, still technically gets the note, but that sensitive information has now been redacted. Or if you chose, you could tokenize it as well. So again, this is just showing how we can help prevent a potential data exposure by inspecting and masking that data on the response. Great, and with that, we're going to pass it back to Prithpal to go through a more in-depth demo. We're going to show, again, how we can combine the power of our enterprise data protection controls of DLP with the enterprise admin and developer controls of Apigee and Apigee Edge extensions.
Excellent. Thanks, Scott. So that was a great summary of how you can leverage the data loss prevention service and be able to have different tiered layers of protection within the enterprise. I think you did a good job with highlighting an order API example where the credit card information needs to be protected. Maybe that was something which was mistakenly added by the developer, didn't really notice. So let's kind of now bring it back to the same employee example out here. So in this case, what I'm going to do out here is I'm going to actually switch over to revision 3. So one of the first things I'm going to do out here is, now let's start to bring in the power of the data loss prevention API and using the DLP extension that Apigee Edge has. So in the previous demo, I showcased how you can easily configure extensions. I walked you through how the BigQuery extension was used. So in this case, what we're doing is we're limiting the results that's coming back to just one employee, but we'll now show the use of how to use this particular DLP extension and how to protect sensitive data. So I'll walk you through the Apigee Edge experience first. What we've done in Apigee Edge is use a feature called shared flows. So what's a shared flow? Imagine you're an API developer and you're using an API proxy and you're using a bunch of different policies in that proxy. But it turns out as you start to whip up new APIs, there are a consistent set of policies that you may use repeatedly. So we have something exactly for that. I'll just switch over to this shared flows tab out here. And you can see that you have the shared flow which says protect with DLP. And so this shared flow, again, as you saw in the API proxy editor, contains what we call as a bunch of different policies. So all the policies that you saw there, many of them can be added out here to a shared flow. And so the shared flow becomes this common shared execution unit, if you would. So in this case, in the shared flow, I've added a few different policies. First of them is to extract the payload that comes out, and I only want to deal with the first record coming back. And then I'm going to apply a specific template. So if you look at the data set out here and the input that I'm sending in, I'm saying, great, whatever data is coming back from BigQuery, aka our employee data, I want to be able to take and pass in the different elements of the payload out here. And I want to specifically apply one of the DLP templates. In this case, we call it test DEID1. So when I'm passing this request to DLP, the DLP service will take the specific template, apply that on the payload that we're passing in, and we'll see that it will automatically take and protect the sensitive data. In this case, the employee PII data.
Right. And I was going to mention here, what's really powerful about that is by applying this at the policy level, what that really means is you get that protection across the board. This is something that, let's say, again, as your code changes, as the developers go in and, let's say, add new fields or change their code, they don't have to worry about that policy. That policy is just applied across the board. So that way, if a new field is introduced, but that field is something that goes against the policy, it'll just automatically get picked up at that layer. They don't have to think about deploying that policy one-off in their development cycle. They just get that across the board as more of a
great reuse.
administrative reuse. Yeah.
Okay.
That's a great way. And really, when you think of protecting sensitive data, a lot of these cases are somewhere where something inadvertently gets out, or a field is added to a response that someone didn't realize contains sensitive data. So this administrative policy and applying those DLP templates really gives you that added layer of protection and accountability, where you can show that regardless of what's happening on that development side, we have this consistent enterprise-grade control going across our APIs. I think that's a super powerful.
I agree. So maybe just talk for a minute on, let's just take a peek at this template. Maybe you can walk us through this template is out here. So this is the one template that we're talking about called the test DEID1.
Yes. So what we're showing here is we're going to show this test DEID1 template. It's a very, very simple but powerful template. What we're showing here is actually just the JSON representation of a template. The top part just has some of the metadata about what the template is, when was it created or edited, which can be important just to understand when it was last updated. But the main thing we're doing here is we're basically saying, if you find something that's part of our inspection policy, simply replace it with the type. So we have a built-in setting here that says, whatever you find, take it out and put in the type. So if it was a credit card number, you're just going to get the word credit card number in brackets. If it was an email address, you're going to get email address in brackets. So what that does is it gives you a across-the-board layer of protection that still gives you some insights. If you're doing debugging, or you're going in and actually looking at, let's say, a detailed of what data was collected, you're going to get that insight of what happened, what was collected here, what was detected, but you're not going to get the raw PII stored or flowing through your system.
Okay, perfect. So let's actually take a look at this in real life. So coming back to this, here's the shared flow. So I'll go back to my API proxy. And once I go back out here, I'll bring up the employee's API proxy, which is what we were looking at. And I'll go and point it to revision 3. Let's make sure we deploy revision 3 here. So revision 3 is the one where I'm actually invoking the shared flow. So as Scott just spoke about it, one of the key things of the shared flow feature is it's a reusable set of policies that can apply to every API proxy, right? But within that, we were using the DLP template 1. So what we're really doing out here is, once the data goes as part of a request coming in, we do some basic checks. It goes to the list employee flow, which gets the data back from BigQuery. We extract only one record from there. And then on this return, the response side of it, we invoke the shared flow, which now actually uses that template and applies to it. So I'm going to put this thing back into trace mode here. And I'm going to go back to my REST client. And this is the data set that you were seeing earlier. And now let's see, once we apply the template 1, what happens to the data set. Assuming the demo bot was still with us and this kind of comes through, what should typically happen out here is it goes back to the backend, applies the template, and now takes the first record data set and invokes the DLP template. So in this case, as you mentioned, instead of the credit card information, it successfully de-identified the email address and other PII information from the payload without having the developer needing to do anything special. The template took care of this.
Correct. Yeah, and all of this was configurable. What you look for, like specifying that you care about email address, location, and phone number in this example, as well as what we saw in that template, what do you do when you find it? So in that template, again, a very simple configuration, we simply said, regardless of what type was found that we inspected for, I simply want to replace with type.
Okay, excellent. Now let's take this up another notch. Right, so we did one template. You also spoke about another kind of template maybe I think one of the things you've expressed earlier is maybe people don't want to de-identify that, or maybe use some kind of a hashing method to be able to protect any kind of information leaking. Can you talk a little bit about that template?
Sure. And so what we're showing here is an extension of that previous template that we saw. So you'll notice the very first transformation is filled out replaced with type, and we're applying that as sort of a catch-all. So again, we inspect for a certain amount of things. If we find it, we're going to replace with type. But you'll notice right below we've added onto that to say, but if it's an email address, we want to do something different. So in this example, what we've done is a simple one-way crypto-based hash, where we said when that email address comes in, we want to take it, apply a crypto hash, a secure hash that will give us that consistent integrity. So every time that same email address comes in, we're going to see the same hash, and that's going to let us do some additional analytics or capture information here about that email address that we may need, as opposed to simply replacing it with the word. Now, in this example, we're using a simple one-way hash with an unwrapped key. But I wanted to explain a little bit of the flexibility here. We have a lot of other methods. We have two-way methods. So we have tokenization methods that can be basically where you can create a token and you can reverse that token as long as you have the key. We also have methods that allow you to do that with a format-preserving encryption. Using a format-preserving encryption method that will provide some additional integrity for character set and length of the thing you're collecting. So for example, if you have a 16-digit credit card number and you want the output to be a 16-digit number, the format-preserving encryption method can help you do that. There's a lot of power there. The next part is when we look at the key. So normally when you're going to deploy this in a production environment, what you would do is you would use our integration with our cloud key management system, or KMS, to wrap that key so that it's protected here. The key is not going to be stored in the clear, but it's also going to give you that extra layer of protection from an audit or an access control perspective that key also has to be accessible by this platform. So you get, again, additional enterprise-grade control and audit whenever you're doing one of these crypto tokenization or detokenization methods. So yeah, so this template, again, even though it's just about 5 or 6 lines in this JSON file that we've added, we've now done something extremely powerful. We've added the ability to do a full tokenization of those email addresses so that we get rich value out of that data while also protecting everything else that we found with a simple redact and replace.
Okay, excellent. So now let's take this back to the same employee example and apply this new template and see how the output differs from what we had earlier. And again, as you mentioned, this could be this classical scenario of the enterprise deciding to now change the policy and apply just another different kind of mechanism, and in this case, a hashing algorithm. But again, the extension makes it super easy for you to consume that. So at this point in time, I'm going to revision 4, which is now going to actually reference this template number 2, which Scott just spoke about, to use another style of showcasing how you can protect data. So what I've done at this point in time is I have configured the API proxy now to use the second extension, which is the extension of type 2. And I'm going back to the Postman client. I'll run this record, this API call one more time. And if everything works fine, you should notice that instead of de-identifying that email address in particular, we're actually able to just use the hash specification, which was mentioned in the specific template.
Yes, and so what you see here is now that response is going back out, the requester of this API is now getting that hash for that email address. So let's just say, for example, that they are doing some analytics, and having that hash for that email address would allow them to, again, do those analytics based on the hash. But they would not know what the original email address is. So again, you're still securing and protecting the data, but you're allowing them now to see that consistency if multiple responses are coming back at the same hash, they know it's the same email. And that's just a key balance when we're looking at protecting the data, but also minimizing the exposure while also allowing that business process or that analytics to still happen.
Right.
And that's a key balance that we're trying to achieve.
Right. And I think you make a great point, because administrators not only want to know that, hey, we don't want any sensitive data to leave the enterprise perimeter, whether it's both inbound or outbound, and you can use the extension in that capacity, either to the request coming in or even when you send data out. But more importantly, if I was to double up on this, you could take the Apigee Edge analytics features, right, which is pre-built. You can use a policy called as a statistics collector policy, take the payload, and make a count of this specific value. In this case, it's a hash, so it's safe, but that could now give you a custom report of how many times this kind of key was encountered in a specific payload. And there may be some very important information for different stakeholders, so they get a sense of the different kinds of counters, and you can share this report with operators, the product owners, etc. What I want to do with this demo now, go back real quick and just kind of close out with a couple of key things. So what we did out here was, I'm still an API developer, and I'm working at my API proxy level. And although that is great, what if as an API developer, I forget to use the extension? I mean, that's a pretty benign action on my part. It wasn't intentional, but the reality is data is still flowing through there, through the API platform, and we may still be losing out on some protection which we didn't intend to. So here's another thing which can quickly come to your rescue. So we saw the shared flows. We looked at how the shared flow can have a set of common policies. Well, as the administrator or as the person from the compliance team, I could come out here and within this, use this feature called Flowhook. So Flowhook is a system-wide feature. So this gives me as the administrator the ability to say there are 4 entry points into the Apigee API platform. So imagine when you take an API proxy, it gets deployed to an environment, as I was deploying to the test environment for the purpose of this demo. So what an administrator can come and do is say, at the pre-proxy level, before the proxy is invoked, or before I call any target. So you can pick which ones, right? You can click out here and actually pick one of the DLP flows. And by doing that, whether the API developer has used any extension policy to protect it or not, you can come out here, configure this, so you have your bases covered, and you're ensuring that the compliance policy from security perspective is met, and you can exactly use the same 3 policies using the shared flow. The one last thing I want to just touch on real quick is using a template-based approach. You now have the ability, without affecting anything within the Apigee platform, you can essentially just go and update that template on the DLP side and change the policy from that perspective. So it gives you multi-factorial control on how to really control sensitive data from leaving the enterprise.
Yeah, that's a really key point. I think what you've shown here is a key part. The administrator here can now, through these flow hooks, apply that across the entire enterprise. And let's say you have another role, which is your data compliance administrator, that is different than the Apigee administrator and different than the developer. They can go in and have permission to actually change the data protection policy. Again, what we're looking for, what we want to protect against. And that doesn't have to be done by one person. It can be separated. So if your enterprise has a separate roles, you can basically do that. So you get that ease, that separation of control, but also just that accountability that all of this is happening across your APIs. I really like the idea of the flow hooks, because I think it's just kind of that, almost like an easy click deploy and you just get the protection. I think that's really powerful.
Perfect. So let's summarize this thing real quick out here. So what we saw today, what we covered in the session today was, we spoke about how you can use the Apigee Edge API platform to really accelerate your API development by leveraging this new feature called Apigee extensions. We also showcased how you can use the data loss prevention service from Google Cloud to really protect sensitive data within your enterprise perimeter, blocking it from either entering or leaving those boundaries. And then we went ahead and showcased 2 different iterations of how you can use the specific data loss prevention template support from Apigee extensions and use that to really secure the PII information. And then in the end, we summarized how you can advance mechanisms like share flow and flow hooks to be able to secure any kind of breach of enterprise data, any kind of sensitive data leaving enterprise. With that, I think we'll get into some Q&A. Looks like there's some questions which are coming up here.
Yeah, thank you both for great content. We've got a few great questions here. Scott, I'll ask this one to you. We talked about the various data types, sensitive data types that could be identified in mask. Could you tell us a little bit about how that process works? What's the technology underlying?
Yeah, so like kind of how are we identifying these data fields? And we use a variety of techniques for our built-in types. And so what the built-in types are is when you're configuring the policy of what you want to look for, you simply specify the name or the enum for our built-in types, and you get the power of our detection. So let's say, for example, you want to detect credit card numbers. You simply specify credit card numbers, and then we employ different things like regular expression, pattern matching, mathematical checksums, context analysis, all depending on the type. So some types require us to go in and look at the context using power of things like natural language processing and machine learning to really understand what that item is. Other types, we can do really good detection by simply looking at the pattern or doing some mathematical checks. So it's really a balance there based on the type. So we use a variety of techniques. Now, outside of the built-in types, we have two other ways that you can extend the power of DLP. So one, you can go in and build your own custom types. And in that case, you can specify something like just a regular expression. Let's say you have an internal type and it's pretty well defined by regular expression. You can define that and run that alongside of our built-in types. Or you can define it if it's, let's say, not that well defined, maybe it's just a list of things, a list of words. We do support some very powerful word list dictionaries that can scale up to, thousands and hundreds of thousands and millions of entries, depending on how you want to define that. And those, again, can be added into a template or could be pulled straight from a more production environment, like you want to just pull it straight from a cloud storage or BigQuery table. And the second part is you can actually augment all of this. So let's say you have some built-in types that you turn on, you have some custom types that you turn on, but you actually want to refine that. I'll give one example. We use the example here where we were detecting email addresses. But let's say that there's some email addresses you really don't want to inspect for or redact. So one example might be that you're concerned about user data, but you're not concerned about employee email addresses. So you can turn on our email detector, which by definition will detect all email addresses, and then you can simply do an exclusion rule where you go in and say, for emails, exclude anything that ends in, let's say, google.com, or anything that is in this particular list. Like maybe you don't want to redact out support@yourcompany.com or something like that. So there's really powerful things you can do to extend the built-in types, but at the core of how we detect it, again, it's a variety of methods. And then when you're building your custom types for these exclusion rules, you can use the power of context, regex, dictionaries, and other things to augment or tune the detection itself.
Excellent. Thank you, Scott. I think, Prithpal, another question for you is, we talked a lot about the DLP extension. What are some of the other extensions that are used by customers? There's one question about whether we have any extensions on machine learning.
Yes, I think machine learning is actually a very new extension that we just released a few weeks back, which was announced at Google Cloud Next. So I think that's kind of come up quite a bit when especially our customers are playing around with machine learning and they want to be able to do prediction. That becomes a very important scenario. So as an example, let's say you have an API, set up which is serving up a lot of data, and you want to be able to, as part of that, maybe trigger prediction on some kind of a model that you built. So using the Cloud Machine Learning Engine extension, within the Apigee API proxy editor, you can use the Cloud Machine Learning Engine extension and invoke the prediction method, right? So it's super useful for any kind of workflow-oriented use cases as well, where as part of your ecosystem, you have certain things you're doing, and now I want to run some prediction. You can easily do that from there. I think there's another follow-up question around what about the Datadog extension? So let me take that one as well. So today, we don't have an extension to Datadog per se, but if the use case and the goal is to be able to actually have monitoring information being fed into Datadog, we actually have a feature within Apigee Edge called API monitoring, which actually has integrated white box monitoring for all the API traffic. We actually are able to monitor for conditions such as high latency, high error rates. You can configure alerts, and those alerts could be sent to various notification channels such as email or any other system that has webhooks, etc. Right? So if none of those options work for you, you actually also have the ability to use our management API to extract that monitoring data and use it for doing any ad hoc analysis or actionability. Okay, let's see. I think we may have time for one more question out here. The question is, when you tokenize sensitive inbound data, is that mapping back to the original data available in some way?
So that's a great question. So our tokenization methods today are stateless, and sometimes you might look at it as like vaultless. And what that means is we're using secure cryptographic algorithms to do the tokenization. And so basically the incoming value comes in, let's say like that email address, the key that you specify, which is the cryptographic key, those two together will create that token. And that's how we can do, again, repeat the token and create it again. But we're not storing a mapping table or anything like that on the back end. And that allows it to scale and, again, give you the power of controlling the access to that key. But today, all of those are going to be based on that. Now, we do provide a method, again, that's based on kind of AES for format preserving encryption, another method based on the AES SIV algorithm, as well as an HMAC cryptographic hash, which, again, that one is not reversible. It is a one-way method. But we can, again, in our documentation, I think we have a link provided as part of this that provides some more detail on that.
Excellent. Thank you both. I know we have a few more questions that we haven't gotten to, but we'll follow up with those after the webcast. I want to thank all of you for attending this webcast and thank our speakers for their time. If you have any further questions, reach out to us, Prithpal or Scott. And then we also have another webcast coming up in the next 2 weeks. So be sure to keep an eye out for that one. Thank you all. Have a great day. Bye.